Okay, so why are they separated? Because some old hipster caught another hipster tripping on apples. That is all three different trig functions. So there's the sine function, S-I-N-E. Sine is equal to opposite over hypotenuse. All right, and then cosine equals adjacent over hypotenuse. And the one that we're looking at today is tangent. So it's just kind of a good way to help you remember what it is. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Tangent is the only trigonometric function that does not use hypotenuse. So if you look at a right triangle and you're missing something and you have everything but a hypotenuse, it kind of key you towards tangent. Right? It's not clicking, is it? Like, why does this thing exist? So let me let you copy that down. I'll give you the broad strokes of where it's going and why it's going there. And then the rest of the day, we're just going to kind of work off of one half of that worksheet. The other half is going to be for you to do. I like to speed it up because if you don't have a smart calculator, you can't do this at home. You cannot do trigonometry in your head. It's impossible. You have to use a calculator. Right? You can do square roots in your head. It takes a while, but you can do them. There it is. You cannot do trigonometry without a calculator while it's in degrees. You can do trigonometry in radians in your head. Okay? Is everybody good on this guy? This is also on the formula chart. If you ever get lost or you want to steal it for your notes, it has it right here. Sine, cosine, tangent, and all the ratios that it creates. So you can take a little picture of that. Opposite. So here's the pictures. Here's the process of the journey that we've taken. What would you use to solve for x there? Pythagorean Theorem. Okay? So in Pythagorean Theorem, if you have two sides of the triangle, you can solve for the third side. I need you to grasp that concept. Do you have that in your head? Okay? Pythagorean Theorem. The second thing we did was very specific right triangles that had tricks to move from one side to the other. So in this scenario, I have two angles and one side length. That's a 45, 45, 90. I can multiply by the square root of 2 all the way around. Now here's where we're going. Oh, come on. In this scenario, you can solve for x. You have one angle measurement and you have one side length. Can you use special right triangles on this? No, because it's not 45, 45, 90 or 30, 60, 90. Can you use Pythagorean Theorem? No, because you're missing two sides. So you have to use trigonometry. Okay? So we're going to focus on tangent today. Tangent is tripping on apples. Tangent is what? Tripping on apples. Tangent is opposite over adjacent. Tangent is tripping on apples. That is what it is. So if I write it out the whole way, it's tangent of theta, which is equal to opposite over adjacent. And theta is the placeholder for the angle that you are describing. So theta in this case could be x or it could be y. We never trig at the right angle. All right? So if I'm asking you to find the tangent of x, what is your theta in that scenario? X. So I'm asking you to tangent from angle x. Now tangent is opposite over adjacent. What is opposite of x?
3.
What is adjacent to x? So the tangent of x is the ratio 3 over 3. Yes, sir.
Isn't 3 and square root of 2 also adjacent?
No. Okay, so there's 3 parts of our triangle. There is an opposite side, there is an adjacent side, and this is the hypotenuse. I understand it is adjacent, but more specifically it is the hypotenuse. So you can go in there and label each one. This is opposite, this is adjacent, this is hypotenuse, and tangent is opposite side over adjacent side for angle x. What if I wanted to tangent of y? Tangent of angle y, now that's right here.
So 3.
Okay, the opposite side is now this 3, and the adjacent side is now this 3. So setting up the ratio, 3 over 3. Okay, guys, I love tangent. Tangent's really easy to understand. Opposite over adjacent, never look at the hypotenuse for tangent. Okay, so we're going to go through some scenarios today. I'm going to go through your notes, and we're going to set up every single tangent ratio, all of them. We're not going to solve anything. Then we're going to go back, and I'm going to teach you how to solve them specifically. So good practice setting them up. You have to set them up correctly before you can attempt to solve them correctly. All right? So I think I'm on the examples paper. It says find the tangent of G. Or what does that say? I lost the instruction. No. Just write the ratio. Just write the ratio. So tangent of G. The tangent of angle G is equal to the opposite side. That's all I need. There's no sense in simplifying, because your calculator does all the math for you. Is that okay? So now if I tangent from the other angle, if I tangent from T, the tangent of T is equal to
16 over 8.
Are you okay with it or no?
Are you not allowed to tangent for E?
You cannot tangent from E. I was hoping I wouldn't ask, but why? Because what is opposite of E? Hypotenuse. So you can't tangent with a hypotenuse. Yeah?
Yeah.
Okay, now I want you to make it very clear. Every single one of these triangles is what kind of triangle?
Right triangle.
Okay, so you can use trigonometry for right triangles. So the last one here is still find the ratio for P and Q. You will never see anything this easy on your test, so celebrate it while you can. We're looking for the tangent of P, and I like to color the angle. You don't have to if you don't want to. What is opposite of P?
7.
And the tangent of P is 7 over 24. Okay, now if I'm going to tangent from Q, or the tangent of Q, (24 over 7). Are y'all seeing a pattern at all?
Yes.
If you flip to the opposite angle, it's the reciprocal of the other. Okay. All right. So I'm gonna run through the next 9 questions with you guys. It is very specific. You have to tangent from a specific angle, and you have to give the specific tangent. All we're doing is setting it up. We're not doing any solving. Okay? So make sure you write it somewhere where you have room to solve it later. Number 4. I want to use the tangent ratio, and what angle should I tangent from? Why am I tangenting from C? That's where X is. So instead of writing the tangent of C, I want to write the tangent of the degree measure they give me. What is the tangent of the degree measure? X. So I'm going to write the tangent of X, because I want to solve for X, is equal to what ratio? Boom, and we're done. That's what I want. That's setting up tangent. Any questions on why I did it that way? No? Okay. Okay, number 5. I have to tangent from a very specific location to get the result. To solve for that X, where should I tangent from? D. I need a tangent from angle D. So tangent of the angle measure, it is X degrees, is equal to the opposite over the adjacent. 9 over 12. Yes, sir. No, because tangent does not use the hypotenuse. Tomorrow, sine and cosine will use the hypotenuse. Okay? Huh? Uh-oh. Tangent of X is equal to opposite over adjacent. What happens if you had accidentally put tangent of X equals 5 over 10? It would be solving for this angle, not this angle. Okay? What? Same thing, guys. What angle do they give you? So you want a tangent from that angle. The tangent of 55 degrees is equal to opposite over adjacent. So there's 3 things that I can change. I can change the degree measure, I can change the opposite, or I can change the adjacent. And there is ways to solve for all 3 of those. Does that kind of make sense? I have to have at least 2 values, either one angle or 2 side lengths. Where should we tangent from? The tangent of 35 degrees is equal to X over 20. Are y'all experiencing some success with this?
Yeah.
Okay, so I'm going to speed it up a little bit. I don't know how many more we have left. What's this one?
10, 62, 10
Degrees.
degrees.
C or no? Okay. Tangent 32 degrees. I'm going to be picky about that. Equals what?
15.
Perfect. Is anybody concerned why I'm putting parentheses there?
So you don't multiply.
Your calculator does that. I just want you to be comfortable the way it looks. Is that the last one, or we got 2 more?
One.
Is this a hard one? Go ahead, Lupe. Tangent of 25 degrees Close. 12 over x. Opposite over adjacent. All right, last one.
So tangent of 65 degrees equals x over 3.
Okay, that's it. All the math is done. All we gotta do is and get an answer.
Really?
Now, okay. If your calculator does not say DEG right there, you can do all the math exactly right and get all the wrong answers. Is anybody's calculator in the wrong language?
DEG.
It has to say. Okay, now I'm going to try it for an example. I'm going to type this in just for fun because it makes me happy. Tangent 45. I get 1. What do you get? All right, the trig button? Yeah. 1.8. 1.6197. How is she getting 1.6197? Because your calculator's in radians.
Oh, it's in degrees.
You need to put your calculator in degrees. So I want everybody to pay attention to how this works in case some idiot before you changes it. Because that's exactly what happened. Okay, we have to go home. 5, 2, angle has to read degrees. Once you do that, please hit make default. So make it a default and hit OK. And you should be good to go. Now it should read DEG up here. Huh? You good? Okay, so let's get back to the magic. I'm going to scroll back to the first example where it asked us to math. Ooh, number 4. Okay, there are 3 different scenarios. You're solving for a numerator, you're solving for a denominator, or you're solving for an angle measurement. Okay? Whenever you solve for an angle measurement, I have to get x by itself. So how do you get tangent over here? This is tangent times x. So you divide by tangent, it does not become 1 over tangent, it becomes the inverse of tangent. Do I really care if you understand that or not? Here's what I want you guys to think about. Pay attention to this. Okay? He goes from the west side to the east side, and he loses a life. He's a gang member in the wrong territory. -1 life. So now it looks like this. X equals tangent minus 1 life of that fraction. So it becomes tangent -1. So here's what I want you to think. If you're solving for an angle measurement, you use inverse tangent. And that's it, guys. That's what you slam in the calculator. Watch. Mira, look at me do it. I'm about to do trigonometry. If my calculator will open up. So I hit the trig button. And I'm going to do inverse tangent. It's right there. Type it for you. Inverse tangent of 12 divided by 5. Boom! 67 degrees. That's how big that angle is. Try it for yourself. So how big is x? 67 degrees. I'm pretty sure sorry. I didn't read it. My bad. Nearest thousandth. It's 3 decimals. 67.380. 67.380. Now I'm going to nerd out just a little bit. You don't have to do this if you don't want to. I'm going to find the tangent of B. I'm going to call that angle Y. So the tangent of Y is equal to opposite over adjacent. I know homie's gonna go to the east side of the tracks, lose a life. It's gonna become the inverse tangent of 5/12. Trig, inverse tangent of 5 divided by 12 now. Oh, 22.62. I wonder if 22.62 and 67.38, 22.62.
No, you did 2.
It's a calculator. 22.62 and 67.38 and that 90-degree angle. Holy Jesus.
Whoa.
It solves for every angle in the triangle and it exactly adds up to 180 degrees. Technically you can add the two that are not the hypotenuse and it should equal 90. So if it ever asks you to solve for both, take the one you get, subtract it from 90. So this is what trigonometry does, right? Trigonometry will help us solve for missing angle measurements. You can use the interior angle sum to solve for y, or you can use trig to solve for y. Alright? Alright, number 2. We are solving for an angle measure. What kind of tangent are you going to use? Inverse tangent. So you can kind of justify that x will be equal to the inverse tangent of 9/12. It's just how you type that in the calculator. Do you need help? Do I need to show you that again? I like to do this sometimes. I always do that. I'm going to do it. Inverse tangent. I'm kind of one of those control divided by people. I was for some things. 9/12 because it looks like my paper. It doesn't really matter. So nearest thousandth, 36.87. And if you wanted to solve for the other angle, you could just flip the fraction. Flip that fraction, 12/9, 53.13. That would solve for the other one. And those two add up to 90 and make 180 degrees in the triangle. So, what do you do to solve for an angle?
Inverse.
Inverse tangent. That's something I need you guys to connect in your mind. When you're solving for an angle, use inverse tangent. Is that going to change for sine or cosine? No. If you're solving for an angle, use inverse sine or use inverse cosine. Okay? I wonder what I'm going to do here.
You're going to use inverse?
I bet you at that angle, 60.
63.435.
Oh, I was wrong?
Yeah.
X equals tangent -1 of 10/5. You could be smart and just put tangent -1 of 2. It's like actually 3. It's actually less work to do that because 10 divided by 5 is 2. What did you get? 50.
63.435.
Yeah, is this okay with you guys right now?
Yes.
The next part's confusing.
The next part's confusing, but don't worry. I have great Baker tricks.
Sweet.
Okay, I have to show you the long way first.
That's done.
You're done. And then we can celebrate shortcuts, all right? So I'm trying to solve for x. Now, something I need to get across to you guys. This is an angle measurement. This is a side length. These two numbers never talk to each other. They don't. So, this is the easiest way to explain it. Cross multiply. X times 1. Tangent 55 times 4. No. Angles do not talk to side lengths. It is 4 tangent 55s. That's it. You slam that in the calculator. 4 tan 5 5 enter. That's the long way.
Enter.
For regular tangent, 5, 5. 5.713. 5.713.
That's weird.
Whoa, whoa, whoa. Hold on. Hey. So you could use Pythagorean Theorem and solve for the third side. Here's Baker's trick. Are you ready?
Yes.
You have to understand the trick to use it. If there is a number in the denominator, he gets a fast pass to the front of the line. 4, 10, 5, 5. You see that? If there is a number as the denominator, he just goes to the front of the line. Okay? Now, it's a good trick and it always works. Hey, what? There's a number as the denominator. I wonder where it goes. It goes to the front. So now we're getting 20 tangent of 35. 14.
Oh yeah.
You finally like math again?
Yep. Yes.
Next one's stupid.
Why is the next one dumb?
Because the x is the denominator.
Okay, so now, is there a number as the denominator? No. So my trick will not work here. So let's do it the long way and see what happens. 10 times 1.
10.
X times tangent of 62. X tangent of 62. How do you get x by itself?
You
Divide by tangent of 62.
10.
So, well, hold on, okay? So look at how it started. It was tangent of 62 equals 10 over x, and it wound up as x equals 10 over tangent of 62. So what happened here was the denominator and the answer switched locations. So if there is a number, a variable as the denominator, you can take those two terms and swap them locations. So you gotta type in 10 divided by tangent of 62. I prefer to use the control divide method. 10 divided by tangent of 62. 5.317. And that's your answer. Yeah or no? So those are all three scenarios. Go ahead.
No, I was just gonna see if you could like explain it one more time.
The how it works when there's a
No, how it works when there's an X.
when there's an X in the bottom. I think I have another one right here. So in this scenario, because there is a variable as the denominator, this and this swap locations. That's the easiest way to explain it, and it will always work. Does that make more sense? So now we're trying to type in 15 over tangent 32, and we're trying to expect to see what x looks like. 7 something?
Wait, which one? 10? Yeah, it's 24.005. 7 something.
I don't know, I was just guessing. So it's really hard to do trig in your head.
Would have to be bigger than 15.
That's what I thought it was the other way. I labeled my triangles wrong. It's like 1, 2 square root of 3, which is really close to 30. Didn't work.
Oh, that's 25.7.
Yes, sir.
What is tangent?
Yeah, it's a good question.
Why?
Tangent is opposite over adjacent.
Yeah, but like, why do 45 do what?
I'll explain that to you in a second. Is that what you were doing the same thing?
It's just so
So it is a ratio of the opposite over the adjacent. That's all I can say. Okay, let me finish this up. So x on the bottom, what happens?
Or it switches places.
They switch locations. All of this and all of this swap locations. So 12 divided by tangent of 25. 25. Ugh. One more time, Aaron. 25.7.
3-4.
Y'all are really quiet. Y'all like this? You hate it? I know you're like, I don't get it.
I get it, but
You have to. You have to. Tripping on apples. That's all I got.
wait, why are you looking at me?
I don't know. Tripping on apples. That's all I got. Sorry. I just heard female voice. Like this, 12 over tangent of 25. I like to use control divide. I go 12 on top, and on the bottom I do trig, tangent, what was it, 25?
Yes.
That's how you get it. Alright, I think we're good. Y'all, is there anything else I haven't covered yet? So, where does that number go? Okay. This number goes, because it's a numerator,
How goes the front?
fast pass to the front.
And then it's 6.434.
Okay. Alright. Why does tangent of 45 equal 1? Okay. I have it already.
So it is
This is a 45, 45, 90 right triangle. So if I know that this angle is 45 degrees, the tangent of 45 would be equal to opposite over adjacent. Or tangent of 45 equals 1.
What?
You just know.
So the tangent of 45 is
1. That's it. I mean, so like, I don't want to screw this up. The tangent of 30 is 1/2. The tangent of 60 is 2. And that's using 30, 60, 90 right triangles.
What's 90? Is it 3 over 2?
What?
You can't
The tangent of 90 is undefined. Is it type in your calculator?
Yeah.
You know why it's undefined? Oh, shit, here we go. Here, my homeboy, the unit circle.
I don't know.
What is the location of this right here?
0, 1.
Oh, because 90 is
0, 0, 1. What is the location of this one?
1, 0.
So the unit circle goes cosine. So this is my cosine function. This is my sine function. This is my cosine function. This is my sine function. So tangent is sine divided by cosine. So the sine of 90 is 1. The cosine of 90 is 0. That's how you get undefined.
Oh.
That's why it's undefined. But the tangent of 0 is 1. Now, here's where this is going. Once we are like trigonometric professionals, we're going to do trig in radians. Don't fret, my little pets. It's all off of that big unit circle. And you've done all the work already. Just so I can say,
Don't fret, my little pet.
well, hey, at least you're hearing me. If I was going to do the tangent of pi over 4, that is the location, the square root of 2. So the tangent of pi over 4 is 1. Boom.
It's just corresponding.
Because the tangent of pi over 4 is this number over this number. Right? Like the cosine of pi over 4 is the square root of 2 over 2. But you have to put your calculator in radians to figure that out. It gives you the answer. That's going to be great. So whatever else I haven't done on the back, that's for you to work on. You have 10 minutes. Like you have 60 degrees. I'm going to start telling time in degrees and radians now. We got pi over 6 radians left in class. I love my life.
I got 10.
Wait, do we have to do 13 through 18?
The line ones.
Yeah.
Because you brought it up, I have to do it.
No.
Nah, don't worry about it. So it says find the angle made by the line. So 2x minus 1 looks like this, right? It wants you to find that angle right there. And it's really simple. Pick an x value.
2 minus 1.
So 2 minus 1 is
1.
so then tangent is equal to, you went over 1 up 1, right? That's how you get to 2x, right? Is that right? You went over 1 up 1. So my line's my over 1 up 1 is right here. So tangent is equal to opposite over adjacent, or tangent is equal to y over x. So this would be a 45 degree angle. Tangent is always equal to y over x, no matter what. So what if you put a 2 in there? What? Does that even make sense?
4.
No.
If x is 2,
It's 3 over 2.
Over 1 and up 2, isn't it?
huh?
It's over 1 and up 2, not over 1 and up 1.
If x is 2, then y is 3. So it would be over 2 up 3, which would be 3 over 2.
Oh,
It's this is why I didn't want to do this. Tangent is described as y over x.
Okay.
Okay.
So it'd be 3 over 2.
So in this scenario, if you put a 2 here, it would return to 3, and it'd be 3 over 2. And you'd do like inverse tangent of 3 over 2. Skip that section. I don't want to do that.
Alright, good call.
That wasn't entirely prepared to, and I think it showed. Like
Is that on our list? 13 through 18.
yeah, that whole bottom chunk, all of this. I wish I had a good way to explain it.
On the back side.
No, yeah, so the whole back is yours. None of those lines are on there. Are there lines on the back too?
Yeah.
Yeah, then 10, 11, and 12 you can skip. Now I want to know how this works.